turn it over to Jiwan. Joe, I'm not going to say Jiwan. I met Jiwan. He ran a Python group over at UTSA, and he's a PhD candidate. He's going to be receiving his PhD this December. So your background, you were an electrical engineer for his bachelor's, and now he's doing cybersecurity, I think with a focus in the kind of the electrical engineering side, which falls under the OT. So, thanks.
Like I said, my name is Jiwan Ninglekhu. I've been in UTSA since 2011. I did my master's there and in computer engineering, and then switched over to PhD program where I investigate. My research area is in computer security. Now it's called cybersecurity. It's a cybersecurity kind of covers the big abstract field, but my specialty is in access control. Access control especially deals with authentication and authorization. And this talk is typically for authentication only, but most of my PhD work was on the authorization side. So Dr. Ramakrishnan is my advisor, and we have this group of people. Dr. John, he brought the idea, and we consulted with Manoj Pandey, who is a cardiologist and is a master of doctor, I don't know. So he works at University of Texas Health Science Center as a cardiologist. So the title of my presentation today is Securing Implantable Cardioverter Defibrillators, or also called ICDs, using smartphones. As we might know, in academia we have to do something new, and we have to investigate the things that actually, especially in academia, people have research, and we have to build our research on top of what exists. So I would also like to thank everyone for coming, and especially Stephen for inviting me. So implantable cardioverter defibrillators are especially used to treat a disease called arrhythmias, and it also contains something called pacemakers inside them. And overall, it senses the activity of the heart, and if the patient has too slow heart rate, then it provides some corrective shocks so that it beats, the heartbeat comes to the normal beat. And it is implanted inside the human body by performing surgery, and it typically remains inside human body for about 7 to 10 years. And therefore, putting inside and taking out the device itself is kind of complicated. So we have to also take care of the power. It is powered by battery, size of the pager, and this is not the latest one, but I could not find the latest data. But about more than 3 million people have implants. So now there is a device called external programmer, which is actually used to extract information or for doctor to design the type of therapy that the patient needs. So what it does is it has this magnetic wand which is extended from this device, which is put on top of the skin, and it has magnetic wand which opens up a port inside the ICD, from which a wireless connection is made, and the data are extracted, or some programming needs to be changed inside. But now, due to the advancement in technology, we have different kinds of wireless access. There is a device called Medtronic transmitter, which is placed few feet from the patient, which actually is able to transmit and receive data from ICD, and it's sent to the doctor via the internet. There is also a telemedicine, and there are some fully wireless, which is placed again and then few feet from the patient, and data are collected and sent to the doctor via the internet or into the database. Now, what is the problem? There are some group of researchers, Halprin et al., there are a group of people, there are so many people who found out that there was no access control in ICD. The problem they found was any external simulated external programmer, which I will call EP, could actually communicate with ICD and deliver lethal shocks if necessary. Although it's not in practice, although it's not easy in practice, due to the recent advancement in technology, it is feasible. And also the communication between these two devices were unencrypted. But this was found around 2010, 2011. And series of work has been done to address this same issue. Some of the previous researchers proposed a cloaker, some other researchers proposed external shield. You know, you have seen in some advertisement that they put like a medallion and then that would actually control the access. But even then, they had some limitation which my research would address, is that they had unprotected communication during emergency. Patient wouldn't know if somebody is trying to access their IC. And they also designed the research in such a way that unknown external programmer or some new external programmer would not be able to access their ICDs. And there are some more research which actually used, there is this research by Zhu et al. They used the key exchange mechanism by taking the ECG signal from heart and ECG signal from the wrist, and two devices would exchange the symmetric key between these two devices. But they did not provide the accuracy, how accurate these two devices would be based on time and space. So I think they have, they must have given some clear concept on how, but they lack that. So one of the things we have to remember in implantable device or any medical device is that there's something called safety. In the case of emergency, they have proposed that all the security must be taken off, so that in the case of emergency there should be no hurdle in taking out the data from ICD. But we still think that even in the case of emergency, the communication should be encrypted and the data must be secure. So we found out those limitations, that they did not address some unknown external programmer, because if the patient is traveling to another city and wants to change the therapy, then the ICD must be able to receive or respond to an external programmer with authorization. And the communication must be protected during emergency as well. And patients should be aware of any unauthorized access, or at least patients should be able to know if somebody is trying to access the ICD. So we'll address, in my research, I've addressed these problems. So to do this, I proposed something called smartphone to control this access. So it will be able to control who can access the ICD, facilitate secure communication between external programmer and ICD, and notify any activity to the patient. And since this ICD also behaves as a monitoring device inside the human body, it is able to send out signal to the smartphone. So we chose smartphone because more than 2 billion people will have a smartphone in 2017. Even many patients carry phone, and so on and so forth. So the basic idea is that we propose that external programmer must be able to have authorization. Must be authorized before it can access patient ICD. So what we did is that external programmer must first contact the smartphone, which in turn would communicate with ICD, and upon the consent of patient, the smartphone would be able to share a key. Should be able to provide a token, which using that token, external programmer can actually access ICD and extract information. So to do this, we have addressed 4 different practical scenarios. So first one is clinical consultation, where we assume that the patient must have a smartphone, and there may be a situation where patient may forget smartphone, so we must also address that. And there may be 2 different conditions: unregistered external programmer and pre-registered external programmer. And we must also address the situation or scenario where patient is incapacitated, but if the trained medical professionals came, then they should be able to use a smartphone to access the information from ICD. And if patient is incapacitated and smartphone is absent, then we also must address that situation. So first scenario, it's a hospital scenario where this patient is at the hospital and doctor is trying to use this external programmer to access ICD of this patient, and the external programmer is unknown, new one. So it first requests access to the smartphone, and the smartphone displays whether this external programmer should be allowed or not. And upon the consent of patient, it provides a shared secret key between smartphone and external programmer. And based on that key, the token is sent to external programmer, and the same token is sent to patient ICD. So based on that token, it extracts the key, and with that key, it uses a temporary key inside the token to exchange the messages between external programmer and ICD. In second scenario, if the external programmer is already registered, then again most of the scenario is same. It first requests for access to ICD through the smartphone, and patient is informed about somebody is trying to access. Given the consent by patient, it does the mutual handshake between a smartphone and external programmer, and then a token is sent, a symmetric key is sent via token to both the devices, and based on that key, two devices can exchange the messages between two. In second scenario, when patient is incapacitated but has a smartphone, then what we could do is that since ICD is listening continuously to the patient's status, it will know that patient is incapacitated, and it will send an alert and a temporary secret key on the smartphone screen. If the patient is able to react, the patient will of course call somebody or send a text. Otherwise, given that emergency medic or health professional arrives on the scene, they can still use that temporary key on the patient's smartphone and use it to extract the information from the ICD. Scenario 4, if patient is conscious but is without smartphone, then we have designed this scenario in such a way that a patient can, in this situation we have assumed that EP is able to scan, either take the one-time secret key or scan some biometric information from a patient, so that that key can be used to extract information from the patient ICD. And the fourth scenario is where patient is incapacitated but without smartphone. In this case, again, EP can take the biometric information, in this case, of course, fingerprint. It can take the fingerprint from from the patient and extract the information based on the key derived from this fingerprint. In all these cases, in the last two cases, we have assumed that the fingerprint or the key that is derived from the fingerprint is stored in the patient IC. So to conclude this research work, in this research I presented approach using smartphone which could address the real world scenarios which the previous researchers could not address. Smartphone could facilitate any external programmer to communicate with ICD. And also we put we put the patient himself or herself into the security loop so that the patient is informed about who is accessing the ICD and has authority to either allow or deny that access. And even in the case of emergency situation, the channel is encrypted. In this demonstration, what I used advanced encryption standard (AES) encryption algorithm with 256-bit key to encrypt the messages between these devices. So the future work is that what I did was I actually demonstrated this and developed a proof of concept by using two different computers to simulate the ICD and the external programmer, but I used the Android smartphone to actually be able to respond to this requests and acknowledgements. But it is still needed to be implemented in the actual ICD, and it has not been done yet. And I don't think anybody has done it yet. And power utilization is a big issue because these ICDs are implanted inside the human body for, like I said, 7 to 10 years. And implementing this security on top of existing communication, I could not measure the power consumption, but I could find the ratio with the line of codes that I wrote. So line of code that I wrote with the encryption in place was about 2 times more than the existing without the encryption key. So that would, we can estimate that would roughly take 2 more times the battery power to process the same communication. So if it is 10 years, it might reduce it to at least half. So a lot of work is going on in power utilization, in developing power efficient chip, but there can be some trade-off to still save power. Again, not all cyber attacks can be addressed with this solution. Because, for example, one cyber attack, a port in ICD is always listening. So although an adversary cannot actually get inside the ICD, it can keep on requesting. So while it is requesting, the ICD will just respond, you cannot access, you cannot access, you cannot access. So in that scenario, if the adversary keeps on doing that for a long time, then can still drain the battery, and it can affect the patient. So in all these scenarios, only one identity was used, that is the identity of these devices. An AES 260-bit encryption was used, and to mitigate the man in the middle attack and replay attacks, nonce and timestamps were used, and all the keys that were exchanged between these devices were temporary keys, which would expire after given time. So maybe 10 minutes or so. So it would be useless. Those keys, if somebody in the middle tried to extract it, it would be useless after 10 minutes. So what we can learn from this into control system? I haven't explored that much control system in a while, but since control system is moving into industrial IoT, we will be using what if we use internet or anything that is on top of network level, then we have to implement some form of security of this nature. So in this research, I used Kerberos based authentication architecture because the purpose of using Kerberos was because it uses symmetric key encryption algorithm, and to have asymmetric key such as public key cryptography is expensive. In how many devices you can actually put this, and the computation would be very tiresome. That's why, given the scenario, I use Kerberos, but other encryption or other authentication algorithms can be used. And since industrial control system involves a lot of sensors, again those sensors, the data is collected from the sensors. If it's wireless, for example, can go to one transceiver, and from that transceiver, so from that particular transceiver, it is, I think, important to encrypt the information. Again, if the sensor or the type of device that is sending or sensing the information is too tiny, doesn't have computing power, then the security architecture must be designed in different way. In this research, I use only system IDs as their IDs, right? But other access controls, such as role-based access control, attribute-based access control, and hybrid of these two can be used to make it more robust. For example, if the device is located in a control system scenario, if the device is located where there is temperature must be between 30 to 60 degrees, right? Then we can actually use that information to control access using attribute-based access control. Time, who is accessing the data, and who allowed that person to have authority over those systems, or we can divide the system, we can divide each device into category, and based on the information that can be extracted from all these devices, we can still use the authentication algorithm such as that I have used in securing ICD in control system as well. So thank you, and if any question.
I have a question. Now, saying your heart talks to a device that generates key, correct? Is it something that the person that's carried with them everywhere, or would it be with the EMT, or so it generates a code for the phone?
I'm not sure what you're saying.
You know how you're saying that the device will talk to something?
Smartphone. Yeah.
The smartphone, right?
Yeah.
And it'll generate a key. So is it that?
The patient is entering the key.
The patient.
Oh, okay.
So he has an option to where if the patient has a smartphone, it will go to the smartphone that he will have access to. But in the scenario where the patient doesn't have a smartphone, it would be fingerprint or any biometric system for them to use.
Okay, that's all right.
It come across like a release of information, like email, and then you put in the PIN.
Yeah, okay.
And so on.
All right, that was my question.
Do you have a follow-up question?
My question was, when you did the 4 scenarios about the patient with the smartphone and the patient without the smartphone, then you had the incapacitated with and without the smartphone. As far as, a whole lot of requesting of information stuff, especially like if they're incapacitated with or without a smartphone, was there any type of suggestion or anything of having like a backup, like a SIM or a memory card in the ICD, just in case? So like paramedics came, instead of having to go through all the whole process trying to request access, they can take the memory card from the ICD to take with them so they can understand the process. Because I would think that using a little small storage device like that would help, with the transmission of the data.
Yes, that's a good point. And somebody in Finland actually tried to propose this. saying that they can add some extra disk or computing little chip inside that would help. Again, the main problem is that these devices are implanted once and then taken out only after 10 years.
Mm-hmm.
So it's infeasible to operate and take that out frequently.
Okay.
Yes, and now the main problem with these devices is battery power. That may be one of the reasons, I don't know, but that may be one of the reasons that they haven't thought, or the industries haven't thought about implementing all these security features inside them.
Okay.
So, but that is I think, good point.
Well, either that or the external device out there that is reading to, like how you showed the example of like.
The original transmitter that's requesting the information?
Testing, but then there's another, either the device on the side that was tracking what they were transmitting, like they had the device set within a certain feet.
The smartphone itself can actually store the information that is being transmitted. But the main problem that we are trying to address is nobody should be able to get into the ICD so that the program that is inside can be converted. Or, if somebody converts, then it will provide like 10 volts then per person.
I did recently read an article where actually the pacemaker itself is being at hazard for being hacked itself. Recently in San Francisco, they actually are recalling some of the parked pacemakers. Is there anything that's going at that point where you would have to secure the pacemaker itself as well?
Well, that's something new I didn't know. But I know that there has been a lot of recalls, and some of the research is trying to address why they have been recalled. So protecting the ICD itself?
Right.
From what?
So I understand the concept of where you're protecting the transmitter and the smartphone from being hacked, which is the whole point of having the cell phone involved. But wouldn't there still be a way around, just to be, instead of going from point B to point A, to just go straight to point A and hack the pacemaker itself? Would you have to go and do a security feature for both the transmitter and the pacemaker and then the phone as well?
I think
That's
part
what
of
this
the- Part of
does.
the reason that I think she's asking that is because you mentioned that it travels with a symmetric key.
Yeah.
So if a hacker intercepts the message, he can also intercept the key. Because it's a one-way hash.
Yeah.
And
Well,
I
like
think
in
that's
movies,
part of
As you
the-
said, for the request, when they request
Basically
it.
kill them is what they do.
I'm not.
Can you go back to the diagram we had,
Just continuously shot.
As the information travels, it travels.
we'll
with
use this one for example.
The one-time key, right, the symmetric key? 256 key?
Yeah.
All right, that one right there.
Which is a one-way key, so if a
So
hacker intercepted the phone transmission with something like Wireshark, they can actually intercept the packet of the one-time key along with the message,
And then, data.
and with enough malicious intent, in the long run, perhaps intercept the E EP.
Especially if it's all going to be on the same network, run together.
Yeah.
That could be possible. I'm quite not sure about that. What we've done here is once they have exchanged the main key, right? Main symmetric key, every time they're using the temporary key. And even this message have a time. N1 is a nonce which will be valid only for a few minutes if we want to. So this can be changed if needed. That will, I think, not eradicate, but mitigate to some extent. I think if somebody's trying to read this exchange for a long time, every time there's communication, the key will be changed. So I think the person still will have some hard time trying to find it.
Do we know of any, sorry, go ahead.
Oh, okay. So if someone was, I get the encryption part, but how would a person know, if two people are trying to communicate with their thing, how do they know, Dr. A and not Dr. B?
Yeah.
Because is it just will you let this machine read it, or is it do they know who's actually behind the machine? Does that make
That would
sense?
probably fall under the hospital access part.
Well, it'd be the app he made. How
Yeah.
And then,
So, there has been some assumptions made here. So, whenever first time the ICD is implanted, there are some keys such as the key from the fingerprint is put inside the database, and the first time when this unknown device comes into play, the person puts in one symmetric key, right? That symmetric can be changed whenever the person requires. But to answer your question, the doctor, I did not cover that part to be specific, but that can be addressed. I think only registered doctor with registered device can it can be designed in such a way that only registered doctor with registered EP could access this.
so my question is, so say they go on a vacation, their doctor is back in Florida and you're in Texas,
Yeah.
and like you're having problems with your pacemaker, would you have to contact your doctor in Florida to get them to send over a key in Texas? And if,
Manufacturer or something like that.
yeah,
No, the second scenario that addresses just that. If the person is traveling to some other location, then again, the patient is responsible whether he wants to allow any external program or not. So the patient goes to the clinic, and provided that he knows the doctor, and the doctor will take some external program and try to access, right? So it will pop up some message, would you like to allow this or not? And the program is designed in such a way that it can be just treated as one-time external program to allow it to, so there is a risk in that the patient has to have trust with that doctor and the external program itself.
So this process is going to work even if you're incapacitated, correct?
If you are incapacitated,
Yeah.
what do you want to do if you...
Well, the thing is this right here, is maybe I'm having a little confusion, is when you was doing a scenario of the two, patients alive, no smartphone and a smartphone, but the other two was incapacitated
Yeah, we
patient.
can go to this slide. So...
Yeah, incapacitated with or without a smartphone, either one.
Yeah.
He's non-responsive. He can't do anything. His phone is there or his phone's not there. And either paramedics or emergencies are trying to gain access to his EP to read his ICD. That right there is my issue right there, is because if he's incapacitated, unable to get it, regardless of his biometric, aren't they required to have a secret code for them to gain? That's where my thing was coming in, as far as like the SIM card or the memory card for not the ICD but the EP was more the thing, because EP is collecting all the data, right? It's getting it from the mobile device or the ICD, correct?
No, EP is just used to program.
Okay, it's just for
Yeah,
program.
whenever you want to program it,
Mhm.
if you want to install a new set of therapy, for example, right?
Mhm.
So you program it, that's it. And
So
then-
it shouldn't be able to at least be able to collect the data as well? I mean, I
I'm
would
not
think it
sure
would
how they are designed,
Okay.
but I at least know that they are used to program them. So
Okay.
I'm not sure about that. But to answer your question, again, we have assumed this device with scanner.
Okay.
So, and the fingerprint key that is derived from the scanner is stored in the ICD in the time.
So as long as they, scan his rectal or finger or eye or anything, it automatically unlocks for them just based on those two things.
So,
Emergency temporary maintenance.
Yeah.
the EP is used to basically program, and if say their heart's not working, it's basically to shock them, kind of like a yeah.
Yes,
Right.
that's
So that's why they need to gain access, like the EMTs or any health profession.
Right.
That's where they have to gain access to.
So if
It's
the
not just
patient
for
is
information.
incapacitated,
Yeah.
That's why I thought it was that more information.
so the
They don't access the EP, right? They access
What's
the
that?
ICD.
Yeah.
This is more of a medical question. Can you not just use an external defibrillator if they have an internal one?
Yeah, that's a good question. And if the patient is incapacitated, of course, it is better to give external, right?
Uh-huh.
And if the person is in the scene. But we had the same question and we asked the doctor, and he said one thing is that we have to still protect the information from the data, and as a security engineers, it's our responsibility to protect. And even if the person is unresponsive, and many times if the person is dead, that information, maybe for the research point of view or something, it is still needed. So in that case, we still need to. And yeah, I think I also think that it is best to give external defibrillator instead of trying to change the therapy at that time.
Yeah, okay.
Has there been any opportunities for you guys to work with any research companies to maybe take this farther and put it in some type of, beta testing and everything?
Concept form?
No, one of the researchers in my first slide, he is working on developing chips that would be Dr. John is a professor in our department as well. He is working on developing very power efficient chips, especially for these devices. But as far as nobody has approached us, or we haven't. We have filed a patent. That's all I can say on this concept.
Do you know of any cases that, any issues that somebody's tried to like actually intercept or hack patients with?
That just recently happened in
Yeah.
San
Yeah.
Francisco.
It actually happened?
Yeah.
Yeah,
So it was an actual patient, or
I
was it just
posted it
like
on Yammer.
Yeah.
somebody just kind of like showed it on
Didn't they have like a drone fly over the hospital and it fucked up the pacemakers? I saw something about that. I don't know if it's real.
Well, I think this also just proves a point that I think none of the medical devices are actually protected at this point.
So it says almost 500,000 people in the U.S. must update their pacemakers that are vulnerable from being hacked. The FDA recalled for the number of the implantable pacemakers manufactured by Abbott Laboratories to be recalled because of risk that someone could be taking advantage of cybersecurity holes in the vulnerability of pacemakers.
So
Yeah.
it's not in the wild, but
But there's no like known like a person that's actually gotten their
Yeah,
pacemaker
not in the
hacked.
wild.
It's just kind of like somebody came up
Not that we
and was
know
like
of.
using it like
Yeah.
a kind of thing.
that would be a good way to murder someone.
It would.
I can remember a few years ago,
think
there was a concern about,
FDA
Dixon.
published
Oh,
yeah.
That's right.
with
you
the
know, it was in the
recommendation.
news that because he has a
That's how you
pacemaker,
can
that there was
actually
concerns
prevent
that someone
security,
could hack his
but
pacemaker.
until it's enforced, I think it won't be, it is not enforced yet to have security features in any medical device. I don't know, I don't have any idea if somebody, if there is one. So,
I think the reason for that is when they developed all these little concepts, they never thought that somebody would maliciously
right,
want to do that.
I guess
I
the
think
chip has,
one
like,
of the first
memory,
one believes they probably found it in
they'd see
insulin
that.
pumps.
right.
Because this thing concept that you're talking about.
People look at it and say, well, think, oh, it's just a heart attack.
Yeah, they
Pacemaker
thought.
failed, and
And,
But if the like pacemaker itself had a memory chip, like it lasts 10 minutes or whatever,
Right.
and see the.
infiltrated.
So the way they're hacking it is that they're actually listening to the sound waves, the radio wave transmissions that the defibrillator is actually doing.
Oh,
So that's
yeah.
how they're actually hacking it.
You were just saying, I was wondering about
Interesting.
So it's like the physical.
Yeah.
Yeah. So that wouldn't, your thing wouldn't even help that because that's like
Right.
a physical.
So for example, a heavy heavy signal wave can be actually sent remotely to actually affect
Yeah.
that patient, but that can't be stopped with this kind of
this is kind of scary.
security feature. I mean, there is. I don't think. It would be easy to just punch that person, right?
Yeah.
By
Right in
magnet.
the heart.
Oh, yeah.
Just up here is a little bit
But yeah, thank you for listening. If any other questions?
It's an interesting concept. It would be nice if they actually could do a demonstration as far as, with like a hypothetical, like a pacemaker in a let's say, a mannequin or something like that, and just pen test it or something.
Yeah, those guys actually, these guys, Halprin et al. This group of people in, I don't know, University of Michigan or somewhere, they actually did experimentally. But for us, I asked, I tried to get an real ICD, but I could not in the given time because I had to complete this work within 6 months, and then there's.
You got glasses on.
How'd you choose this topic for your PhD?
Yeah.
This is not my PhD work, but initial part of my PhD. This didn't go into my dissertation, but I think there was some news that these devices are vulnerable, and actually Dr. John, one of the persons that I listed, he brought the topic, and my professor thought that it would be interesting topic to explore. So we just explored it a bit.
So it's not part of your thesis, so you still got to do a lot more.
So in PhD, what they do usually is, at least in my department, what they do is they first try to train you to do some research, and this was the initial part of it.
Okay.
And my area is most of my work is theoretical modeling of access control, like how do I specify the user's roles, entities, and what kind of rules that I can write to imagining the scenario that can happen and motivating by all these factors, and designing an access control model, and so that I can take that model and implement it in any system like cloud or.
Right.
What would be the cost, and what would have to be the standard for all hospitals to follow to run this program?
If it was up and
I
running.
have no idea.
$1 bajillion.
It'll have to-
That just has to be further down the line and spoke about it.
Well, so like medical, they care more about it functioning than security. That's a big problem.
Yeah.
Yeah.
Have to know what people know that.
I think there should be some trade-off. Of course, everything security guys, when you propose, they won't listen. And we also think that security must be in place, right? And I think there is some trade-off, like how much security. And there's no measure, there's no way to measure the security, how security is. We just feel, there's a gut feeling that, okay, if we do this, it's good enough, right? Right? At least in these known or unknown scenarios, it can mitigate or at least delay from totally breaking down the system. So I think that is good enough from engineer's perspective.
It's all theoretical until somebody figures out how to weaponize this and potentially cause tens of thousands or even hundreds of thousands of people with a pacemaker to die instantly because of a computer virus.
But it's also
Yeah.
like she said,
That's true.
I'm sorry, I didn't get your name. What's your name?
I'm Holly.
Holly. Like Holly said, when you're in, like our field is technical, but remember sometimes when you're securing too much, you can actually
Make it
avoid the device or the availability of the data to stop functioning. I mean, you're in medicine, you're interested in saving lives. So yeah, too much security can actually be bad for these guys because you don't want the defibrillator to not work because it's so secure. Like, oh, Grandpa, you're supposed to put the fingerprint in the right area. Grandpa's all like, Daddy, well,
Grandpa's
no,
all
it's got to function.
Put a phone
So that's
Grandpa,
why.
where's your
But you want to make
What's the
sure
password?
you don't end up with making it where malware could potentially.
Well, that's the thing. I was going to explain to you in class, but with his little scenario that he put up there, it's actually secure. Even though he's using one symmetric key, it's a one-time pad. And I'll explain that later. But with a one-time pad, well, you do have a broader sense of security. And the authentication, he mentioned 2 or 3 way authentication. So, you have the PIN, you have the password. In some cases, you even have biometrics. So, and then you have different areas of control. You don't control just one unit. There's 3 units. There's the physical person, the ICD, and the EP. So You would have to go and you would really not have to like grandpa to really have this.
Good man. I'm not
You're
gonna
talking about hacking and everything else. I don't know if you're
Where did you want me to
researching
post the
down.
website?
Okay, I mean, who really wants to hack in and find out, you know, just how their heart's working? But on the other side of that, what kind of patient information could they
MeetUp page,
find?
right?
Can they find, you know, the names, their, you know, their social, you know, any kind of, what, is all that stuff stored in there as well on that device?
No. I did not explore, but I did not take that into consideration. We just, my objective was to secure the communication, not the data. So we did not assume any sort of data, but we just assumed that the data extraction process should be secure. So, but there could be scenario where the information must be stored inside ICD, because some unknown external programmer with a new doctor, if tries to extract some information, those information like you mentioned, I think it must be inside ICD as well.
Right, because the competent hacker is not going to care about what your heartbeat is.
That's right.
Like we learned in class, they're normally after some type of financial gain.
Well-
So if it has that other PII information on it, that's what I would see somebody trying to hack it for more than anything.
The
But I
way,
think it-
from what I was reading, is that they are actually translating the radio waves so that they could just overshock it, like he said, or just switch it for standby so that the pacemaker just dies out. You could probably hold it for ransom and let them know, like,
Yes,
hey,
that's a big
Oh,
fear.
there
I
you go.
can
That's a big fear.
turn off your thing.
access
So
to
there
grandpa's
can be,
Get 'em.
there can be many objectives, like the Mirai attack that happened, right? Who knows what was his objective? We don't know. Maybe he's just trying to distract people so that his attack was somewhere else. We can't just say that. We can't just say.
I could see that.
It is.
Yeah, and what is also plausible.
I always think like the worst case scenario.
No, it's
Well, that's like-
too many
I
moving
understand
parts
trying to
in
kill somebody
security.
that way, but why do they care about
Well, 'cause
what
he-
their heartbeat is?
The scenario where they're talking about a ransom
Well,
malware attack.
Two, a lot of people can hack for the data so that they can sell it to insurance companies and raise up premiums.
I thought that's illegal.
Well, you know how you swab your DNA? People are actually using that information to sell to insurance companies to raise premiums as well. That's still not against the law, that's pending.
Johnson died.
Knowledge.
No, not even. If
The
you,
subject that was brought up about the malware, the ransomware, I think the goal of a nefarious actor with that would be to try to hack like a good amount of being able to somehow, I don't know, get data or something to where they could leverage that over a corporation. Because like an individual, you wouldn't waste the time on an individual, it would be like a corporation. where
well,
it's
unless the
extracted.
pacemaker
You
has the
extract those amount
same
of money.
radio waves
Like the
and the
manufacturer or
group,
something.
and then you affect mass people at that point.
Or like Adam just mentioned, you could just wail in the news, right? You just turn on the news, you find out that a billionaire worth, I don't know, $100 billion recently went through a procedure. You just use an engine like Who Is,
Yeah, that's
you
a
get his information,
nice
and you
case.
find out.
Yeah.
Or like the Dick Cheney you
My
mentioned.
name is John Aguilar.
I have a particular set of skills.
I will find
Need
it.
$1 million.
That was shocking.
Particularly
Take that
since
plan.
it's over years.
But I mean, you gotta be afraid of Fred because he's gonna shock you somewhere
All
else.
right, thank you very much.
Thank you.
So, the conversation that started after the presentation, of course, we have to lay the groundwork. That's really what this is about. It is about driving that conversation, getting people interested, bringing up new topics. And I guess saying, I mean, nobody, it's not my field of expertise, but nobody has done a hack. But the thing about it is, you know, the speed that cybersecurity attacks are happening and nefarious actors are getting, well, they're upping their game. I mean, like when I was in engineering school, we were playing around with Arduinos, and then I find out that, you know, you hear on the news that some high school kids are using Arduinos as scanners or skimmers on ITM machines. So, but anyways, it's an expanding field, so that's the whole purpose of what we're doing here.